let's explore the fundamental concepts and essential components that form the backbone of Microsoft Azure. This course is designed to equip you with the knowledge and skills necessary to navigate the Azure ecosystem confidently. Azure, Microsoft's cloud computing platform, offers a vast array of services and solutions that empower organizations to build, deploy, and manage applications and services through Microsoft-managed data centers. Throughout this course, we'll delve into the core architectural components of Azure, giving you a solid foundation for understanding how this powerful platform operates. We'll begin by examining the physical organization of Azure. This includes an in-depth look at Azure data centers, the powerhouses that drive cloud computing. We'll explore the concept of availability zones, which enhance the resilience of your applications and data. Additionally, we'll discuss Azure regions and how they contribute to global reach and data sovereignty. Moving beyond the physical infrastructure, we'll then focus on the organizational structure of Azure. This includes a thorough examination of Azure resources and resource groups, which are fundamental to managing your cloud assets effectively. We'll also cover subscriptions, the cornerstone of Azure account management, and explore how management groups can help you efficiently handle multiple subscriptions. Let's dive deeper into the core components of Azure that form the foundation of its cloud infrastructure and management structure. Regions and region pairs are at the heart of Azure's global presence. A region is a set of data centers deployed within a latency-defined perimeter and connected through a dedicated regional low-latency network. Azure intelligently pairs regions to ensure business continuity and disaster recovery, allowing you to deploy solutions with confidence across geographically distant locations. Availability zones are physically separate locations within an Azure region, each equipped with independent power, cooling, and networking. By distributing your applications and data across availability zones, you significantly enhance their resilience against potential failures or disasters. Azure data centers are the powerhouses that bring cloud computing to life. These sophisticated facilities house the servers, storage systems, and networking equipment that run Azure services. Microsoft continually invests in these data centers to ensure they meet the highest standards of security, reliability, and efficiency. Resources in Azure represent the fundamental building blocks of your cloud solutions. These can range from virtual machines and storage accounts to databases and AI services. Resource groups act as logical containers for these resources, allowing you to manage related assets collectively. This organizational structure simplifies administration, access control, and cost management. Subscriptions serve as the primary unit of management, billing, and scale in Azure. They provide a way to organize resources into manageable groups and control access to these resources. Understanding how to leverage subscriptions effectively is crucial for optimizing your Azure environment. Management groups offer a higher level of organization, allowing you to efficiently manage access, policies, and compliance across multiple subscriptions. This hierarchical structure enables you to apply governance controls consistently across your entire Azure estate, ensuring that your cloud environment aligns with your organization's policies and standards. Let's dive into the fundamental structure of Azure accounts. At the top level, we have the Azure account itself. This is your primary point of entry into the Azure ecosystem, representing your organization or personal identity within Microsoft's cloud platform. Beneath the Azure account, we find subscriptions. These act as both billing units and access control boundaries. Think of subscriptions as separate financial accounts within your overall Azure presence. They allow you to organize resources based on cost centers, departments, or projects, providing granular control over spending and access rights. Moving further down the hierarchy, we encounter resource groups. These serve as logical containers for your Azure resources. Resource groups allow you to bundle related services together, making it easier to manage, monitor, and apply policies to sets of resources as a single unit. For instance, you might group all resources for a specific application or environment within one resource group. Finally, at the most granular level, we have resources. These are the individual services and components you deploy in Azure, such as virtual machines, databases, storage accounts, or web apps. Each resource belongs to a single resource group, inheriting its access controls and organizational context. Understanding this hierarchical structure is crucial for effective Azure management. It enables you to implement robust organizational strategies, maintain clear cost allocation, and enforce security boundaries across your cloud infrastructure. Let's explore Azure subscriptions in more detail. These are a fundamental concept in Azure, serving multiple crucial roles in your cloud infrastructure management. First and foremost, subscriptions act as a billing boundary. Each subscription is linked to a specific payment method, allowing you to organize and manage your Azure spending effectively. This is particularly useful for businesses with multiple departments or projects, as it enables clear cost allocation and budgeting. Secondly, subscriptions serve as an access control boundary. They provide a natural scope for applying role-based access control, RBAC. This means you can manage and control access to resources at the subscription level, ensuring that users only have the permissions they need within specific areas of your Azure environment. Lastly, subscriptions function as a scale limit boundary. Azure places certain restrictions on resource allocation at the subscription level. While these limits are typically quite high, they're important to consider when planning large-scale deployments or high-resource applications. A key strategy to consider is creating separate subscriptions for your production and development environments. This separation offers several benefits. It allows for more precise cost tracking, making it easier to distinguish between operational and development expenses. It enables you to implement stricter access controls on production resources while allowing more flexibility in development environments. It provides a clear boundary for testing and experimentation, reducing the risk of accidental changes to production systems. Remember, you can have multiple subscriptions under a single Azure account, giving you the flexibility to structure your cloud resources in a way that best fits your organizational needs and governance requirements. Let's explore two excellent options for newcomers to Azure: the Azure Free Account and the Azure Free Student Account. Both of these offerings provide an opportunity to dive into Azure's cloud services without immediate financial commitment. First, let's look at the Azure Free Account. This account is designed for general users who want to explore Azure's capabilities. It comes with 3 key benefits. You get free access to popular Azure products for a full year. This allows you to experiment with a wide range of services and understand how they can benefit your projects or organization. Azure provides you with a credit to use in the first 30 days. This credit lets you explore premium services that aren't included in the free tier, giving you a comprehensive Azure experience. You also get access to more than 25 products that are always free. These services remain available even after your initial 12-month period, allowing you to continue using Azure at no cost for certain applications. To sign up for the Azure Free account, you'll need to provide a phone number and a credit card, along with either a Microsoft or GitHub account. It's important to note that the credit card is used solely for identity verification. You won't be charged unless you explicitly upgrade to a paid subscription. Now let's turn our attention to the Azure Free Student Account. This offering is tailored specifically for students, providing them with an excellent opportunity to learn and experiment with cloud technologies. Here's what it includes. Free access to certain Azure services for 12 months, similar to the regular free account. A $100 credit that's valid for the first 12 months. This is particularly generous, giving students ample resources to explore more advanced or resource-intensive services. Free access to certain software developer tools. This is a great addition for students looking to build their skills with professional-grade development environments. One of the most attractive features of the student account is that you can sign up without a credit card. This makes it even more accessible to students who might not have a credit card or who are hesitant to provide credit card information online. Both of these free account options demonstrate Azure's commitment to making cloud computing accessible to new users. Whether you're a professional looking to explore Azure for your organization or a student aiming to build your cloud computing skills, these free accounts provide an excellent starting point. They allow you to gain hands-on experience with Azure services, understand the platform's capabilities, and start building cloud-native solutions without any upfront cost. In this demonstration, we'll use PowerShell Command Line Interface, CLI mode. If you're familiar with PowerShell, you can manage your Azure environment using PowerShell commands. Use the PowerShell getDate command to get the current date and time. Most Azure-specific commands will start with the letters AZ. The getDate command you just ran is a PowerShell-specific command. Let's try an Azure command to check what version of the CLI you're using right now. If you're more familiar with Bash, you can use Bash command instead by shifting to the Bash CLI. Enter Bash to switch to the Bash CLI. Again, use the getDate command to get the current date and time. You received an error because getDate is a PowerShell-specific command. Use the date command to get the current date and time. Just like in the PowerShell mode of the CLI, you can use the letters AZ to start an Azure command in the Bash mode. Try to run an update to the CLI with AZ upgrade. Another way to interact is using the Azure CLI interactive mode. This changes CLI behavior to more closely resemble an integrated development environment, IDE. Interactive mode provides auto-completion, command descriptions, and even examples. If you're unfamiliar with Bash and PowerShell, but want to use the command line, interactive mode may help you. Enter as interactive to enter interactive mode. Let's dive into the foundational elements of Microsoft Azure's physical infrastructure. At its core, Azure is built upon a vast network of data centers spread across the globe. These data centers are the powerhouses that drive Azure's cloud computing capabilities, housing countless servers, networking equipment, and storage systems. Azure organizes these data centers into larger units called regions. A region is a geographical area on the planet that contains at least one, but often multiple data centers. These data centers within a region are networked together with high bandwidth, low latency connections. This setup allows Azure to intelligently distribute and manage resources within each region, ensuring optimal performance and reliability for your applications and services. To further enhance reliability and provide even greater fault tolerance, Azure introduces the concept of availability zones. These are physically separate data centers within a region, each with its own independent power, cooling, and networking infrastructure. By leveraging availability zones, you can design your applications to be highly resilient, protecting them from potential data center failures. The combination of regions and availability zones forms Azure's global infrastructure. This robust framework is designed to offer you the flexibility to deploy applications where you need them, scale your resources as demand changes, and build in resiliency at every layer. Whether you're running a small web application or managing a complex, globally distributed system, Azure's physical infrastructure provides the foundation you need for success in the cloud. Azure availability zones represent a significant leap forward in cloud infrastructure design. These zones are physically separate data centers within an Azure region, each equipped with its own independent power, cooling, and networking systems. This separation is crucial as it creates an isolation boundary, ensuring that if one zone experiences issues, the others continue to operate normally. The beauty of availability zones lies in their interconnectedness. Despite being physically separate, these zones are linked through high-speed, private fiber optic networks. This setup allows for seamless communication and data transfer between zones, enabling you to build applications that are both high-performing and highly resilient. It's important to note that Azure ensures a minimum of 3 separate availability zones in all regions that support this feature. This triple redundancy is by design, providing you with multiple options for distributing your resources and enhancing your application's fault tolerance. When it comes to leveraging availability zones in your applications, the possibilities are extensive. You can use these zones to run mission-critical applications and build high availability into your application architecture. This is achieved by co-locating your compute, storage, networking, and data resources within one availability zone and replicating them in others. Azure services that support availability zones fall into 3 categories, each offering different levels of resilience. 1. Zonal services. These allow you to pin resources to a specific zone. For example, you can deploy virtual machines, manage disks, or IP addresses to a particular availability zone of your choice. 2. Zone redundant services. With these services, Azure automatically replicates across zones. Zone redundant storage and SQL database are prime examples, providing built-in redundancy without requiring manual configuration. 3. Non-regional services. These services are always available from Azure geographies and are resilient to both zone-wide and region-wide outages, offering the highest level of resilience. While availability zones significantly enhance your application's resilience, it's crucial to remember that they're not invulnerable. In the rare event of a large-scale incident affecting multiple availability zones in a single region, Azure provides an additional layer of protection through region pairs. These pairs of regions are set up to provide even further resilience, ensuring your applications can withstand even the most severe disruptions. By understanding and leveraging availability zones, you can design cloud solutions that are not just scalable and efficient, but also incredibly resilient and reliable. Azure region pairs represent a strategic approach to ensuring business continuity and data protection on a global scale. Most Azure regions are paired with another region within the same geography, such as the United States, Europe, or Asia. These paired regions are typically separated by at least 300 miles, a distance carefully chosen to balance proximity for low-latency replication, with sufficient separation to isolate against regional disasters. The concept of region pairs is designed to significantly reduce the risk of widespread service interruptions. By replicating resources across geographically distant pairs, Azure creates a robust safeguard against various potential disruptions. These could include natural disasters like earthquakes or floods, civil unrest, power outages, or physical network failures that might affect an entire region. In practice, if a catastrophic event impacts one region, services can automatically fail over to the other region in its pair. For instance, if the West US region were to experience issues, many services would automatically transition to the East US region, ensuring continuity of operations and data availability. It's crucial to note, however, that not all Azure services automatically replicate data or fail over between regions. In many cases, customers need to configure their own replication and failover strategies. This gives you the flexibility to tailor your disaster recovery and business continuity plans to your specific needs and compliance requirements. Some notable examples of region pairs include West US paired with East US and Southeast Asia paired with East Asia. These pairings are not arbitrary. They're carefully selected to provide optimal performance and meet data residency requirements for tax and law enforcement jurisdiction purposes. By leveraging region pairs, organizations can design highly resilient applications and services. You can deploy your applications across paired regions, knowing that if one region faces issues, you have a backup in a geographically separate location. This approach not only enhances your disaster recovery capabilities, but also allows you to provide more reliable services to your global user base. Remember, while Azure provides the infrastructure and capabilities for region pairing, it's up to you to design your applications to take full advantage of this feature. Always consider your specific requirements for data replication, failover processes, and recovery time objectives when architecting your solutions across Azure regions. Azure region pairs offer several strategic advantages beyond basic geographical redundancy. Let's explore these benefits in more detail. Prioritize recovery. In the event of a widespread Azure outage, Microsoft prioritizes the recovery of at least one region from every pair. This approach ensures that applications hosted in a region pair have at least one endpoint up and running as quickly as possible. This prioritization can significantly reduce potential downtime for your critical applications. Phased updates. Azure's update process is designed with region pairs in mind. Planned system updates are rolled out to paired regions sequentially, not simultaneously. This staged approach minimizes downtime and reduces the risk of application-wide outages that could result from unforeseen issues in an update. By updating one region at a time, Azure ensures that at least one region in the pair is always available. Data residency. With the exception of Brazil South, data continues to reside within the same geography as its pair. This feature is crucial for maintaining compliance with data sovereignty laws and regulations. It ensures that your data remains within the geographical boundaries required by local tax laws and law enforcement jurisdictions. Unique pairing scenarios. While most regions are paired in two directions, providing mutual backup, some regions have special arrangements. One direction pairing. Regions like West India and Brazil South are paired in only one direction. For instance, West India's secondary region is South India, but South India's secondary region is Central India, not West India. Cross-geography pairing. Brazil. South is uniquely paired with a region outside its geography. Its secondary region is South Central US, while South Central US has a different secondary region within its own geography. These unique scenarios highlight the flexibility of Azure's infrastructure in adapting to specific regional needs and constraints. Understanding these additional advantages of region pairs is crucial when designing your Azure architecture. By leveraging these features, you can create more resilient applications, ensure smoother update processes, and maintain compliance with data residency requirements. Remember, while Azure provides these powerful tools for resilience and compliance, it's up to you to design your applications to take full advantage of region pairs. Consider how you can use these features to enhance your disaster recovery plans, minimize downtime during updates, and ensure your data storage practices meet all necessary regulatory requirements. Azure Sovereign Regions represent a unique and critical aspect of Microsoft's cloud infrastructure. These regions are designed to meet specific compliance, legal and regulatory requirements that go beyond what's offered in standard Azure regions. Let's delve into the key characteristics and types of sovereign regions. Isolation. Sovereign regions are isolated instances of Azure, physically and logically separated from the main Azure cloud. This isolation ensures that data and operations within these regions remain entirely separate from the global Azure infrastructure, providing an extra layer of security and compliance. Compliance and legal purposes. The primary reason for using sovereign regions is to meet strict compliance standards or legal requirements. These regions are particularly useful for government agencies, highly regulated industries, or operations in countries with specific data sovereignty laws. U.S. government regions. Azure operates several regions specifically for U.S. government agencies and their partners. These include U.S. DoD Central, U.S. Gov Virginia, U.S. Gov Iowa, and others. Key features of these regions: physical and logical network isolation from the commercial Azure cloud, operated by screened U.S. personnel. Additional compliance certifications such as DoD Impact, Level 5 Provisional Authorization. China regions. Azure's presence in China is unique and operates under a different model. Regions include China East, China North, and others, operated through a partnership between Microsoft and 21viaNet. Microsoft does not directly maintain the data centers, complies with Chinese regulations while providing Azure services, enhanced security. Sovereign regions often come with enhanced security measures. For example, U.S. government regions are operated by personnel who have undergone specific background checks and security clearances. Limited service availability. It's important to note that not all Azure services may be available in sovereign regions. The service catalog can be more limited compared to the global Azure cloud. Specific use cases. These regions are ideal for government agencies handling sensitive data, defense contractors working on classified projects, financial institutions in regions with strict data localization laws, healthcare providers dealing with nationally regulated patient data. When considering Azure sovereign regions, it's crucial to understand your specific compliance and regulatory needs. While these regions offer unique benefits in terms of isolation and compliance, they may also come with limitations in terms of available services or integration with the broader Azure ecosystem. For organizations operating in sensitive sectors or under strict regulatory environments, sovereign regions provide a powerful solution to leverage cloud technologies while maintaining the highest standards of data sovereignty and compliance. As always, carefully assess your requirements and consult with Azure experts to determine if sovereign regions are the right choice for your specific use case. Azure's management infrastructure is built on two fundamental concepts: resources and resource groups. Understanding these elements is crucial for effectively organizing and managing your cloud environment. Resources are the basic building blocks of Azure. Essentially, a resource is anything you create, provision, or deploy within the Azure ecosystem. This can include a wide range of elements such as virtual machines, VMs, databases, storage accounts, virtual networks, cognitive services, web apps, and many more. Each resource you create in Azure represents a specific instance of a service or application component. Resource groups, on the other hand, are logical containers used to organize and manage related resources. They serve as a fundamental unit of management in Azure, offering several key benefits. Organizational structure. Resource groups allow you to logically organize your resources based on projects, applications, environments like development, testing, or production, or any other criteria that makes sense for your organization. Lifecycle management. Resources in a group typically share the same lifecycle. You deploy, update, and delete them together. This makes it easier to manage the entire application or project as a cohesive unit. Access control. You can apply role-based access control, RBAC, to a resource group, which then applies to all resources within that group. This simplifies security management, especially for large-scale deployments. Cost management. Resource groups facilitate easier tracking and management of costs associated with specific projects or applications. It's important to note some key characteristics of resource groups. A resource must belong to one and only one resource group at any given time. Resource groups can't be nested. You can't put one resource group inside another. You can move some resources between resource groups, but this action disassociates the resource from its previous group. When you apply an action to a resource group, like deletion or access control, that action applies to all resources within the group. When designing your Azure infrastructure, consider carefully how to structure your resource groups. Some common strategies include grouping by application or service, grouping by environment, development, staging, production, grouping by department or cost center, grouping by geographic location. The best approach depends on your specific needs, governance policies, and operational practices. Remember, there's no one-size-fits-all solution, and you can adjust your resource group structure as your needs evolve. Effective use of resources and resource groups forms the foundation of a well-organized, manageable, and cost-effective Azure environment. As you build and expand your cloud infrastructure, regularly review and optimize your resource organization to ensure it continues to meet your evolving needs. Azure subscriptions are a fundamental component of the Azure platform, serving as a unit of management, billing, and scale. They play a crucial role in organizing your cloud resources and managing your Azure usage effectively. Let's delve into the key aspects of Azure subscriptions. Definition and purpose. An Azure subscription is essentially an agreement with Microsoft to use Azure services. It provides authenticated and authorized access to Azure products and services, allowing you to provision and manage resources within the Azure ecosystem. Relationship with Azure account. Every subscription is linked to an Azure account, which is an identity in Microsoft Entra ID, formerly Azure Active Directory, or in a directory that Microsoft Entra ID trusts. An account can have one or multiple subscriptions, offering flexibility in how you structure your Azure environment. Subscription boundaries. Azure subscriptions define two types of boundaries. A. Billing. Boundary. This determines how an Azure account is billed for using Azure services. You can create multiple subscriptions for different types of billing requirements. Azure generates separate billing reports and invoices for each subscription. This allows for granular cost management and allocation across different projects, departments, or environments. Access control boundary. Azure applies access management policies at the subscription level. You can create separate subscriptions to reflect different organizational structures. This allows you to manage and control access to resources provisioned under specific subscriptions. It's useful for implementing different security policies for various departments or projects. Organizational benefits. Subscriptions allow you to logically organize your resource groups and facilitate billing. They help in implementing different access control policies for various teams or projects. You can use subscriptions to separate development, testing, and production environments. Flexibility. An account can have multiple subscriptions, allowing for complex organizational structures. You can move resources between subscriptions if your organizational needs change. Cost management. Subscriptions provide a clear way to track and manage costs for different projects or departments. You can set up budgets and alerts at the subscription level to monitor and control spending. Compliance and governance. Different subscriptions can have different compliance requirements or governance policies applied to them. This is particularly useful for organizations dealing with varying regulatory standards across different projects or departments. When designing your Azure environment, carefully consider how to structure your subscriptions. You might create separate subscriptions for different environments, development, testing, production, different departments or business units, geographic regions with specific compliance requirements, projects with distinct billing needs. Remember, while you can have multiple subscriptions, you should balance the benefits of separation with the potential complexity of managing multiple subscriptions. The goal is to create a structure that provides the right level of organization, access control, and cost management for your specific needs. By effectively utilizing Azure subscriptions, you can create a well-organized, secure, and cost-efficient cloud environment that aligns with your organizational structure and business requirements. While a single Azure subscription can suffice for small organizations or simple projects, there are compelling reasons to create additional subscriptions as your cloud infrastructure grows and becomes more complex. Let's explore the key motivations for creating multiple Azure subscriptions. Separating environments. One of the primary reasons to create additional subscriptions is to separate different environments within your organization. This approach offers several benefits. Isolation. By creating separate subscriptions for development, testing, and production environments, you can ensure that activities in one environment don't impact the others. This is crucial for maintaining the stability of your production systems. Security. Since access control occurs at the subscription level, having separate subscriptions allows you to implement different security policies for each environment. For instance, you might have stricter access controls on your production subscription compared to your development subscription. Compliance. For organizations dealing with sensitive data or specific regulatory requirements, separate subscriptions can help isolate data and ensure compliance in specific environments. Reflecting organizational structures. Creating subscriptions that mirror your organizational structure can greatly simplify management and improve operational efficiency. Department-specific subscriptions. You can create subscriptions for different departments or teams within your organization. This allows each department to have its own set of resources and policies. Resource limitations. With separate subscriptions, you can implement different resource limitations for different teams. For example, you might allow the IT department to deploy a full range of resources, while limiting other departments to only specific, lower-cost resources. Accountability. Separate subscriptions make it easier to track resource usage and costs at the departmental level, promoting accountability and better resource management. Managing billing and costs. Multiple subscriptions can be a powerful tool for financial management and cost optimization in Azure. Cost tracking. By creating separate subscriptions for different projects or cost centers, you can easily track and allocate costs. This is particularly useful for organizations that need to bill internal or external clients for cloud resource usage. Budget control. You can set up separate budgets and cost alerts for each subscription, allowing for more granular financial control and preventing unexpected overspending. Optimization. Separating workloads into different subscriptions, e.g., production versus development testing, allows you to apply different cost optimization strategies to each. For instance, you might be more aggressive with shutting down unused resources in a development subscription compared to a production one. When implementing multiple subscriptions, consider the following best practices. Naming convention. Develop a clear naming convention for your subscriptions to easily identify their purpose. Governance. Implement consistent policies and access controls across subscriptions where appropriate. Management groups. Use Azure management groups to organize and apply policies to multiple subscriptions efficiently. Regular review. Periodically review your subscription structure to ensure it still aligns with your organizational needs and Azure best practices. Remember, while multiple subscriptions offer great flexibility and control, they also introduce some complexity in management. Strive to find the right balance between separation and simplicity that works for your organization's specific needs and growth trajectory. By thoughtfully implementing additional Azure subscriptions, you can create a more organized, secure, and cost-effective cloud environment that aligns closely with your organizational structure and operational requirements. Azure management groups represent the highest level of organization in the Azure resource hierarchy, providing a powerful way to manage access, policies, and compliance across multiple subscriptions. As organizations grow and their Azure footprint expands, management groups become an essential tool for maintaining control and consistency at scale. Key aspects of Azure management groups. Hierarchical organization. Management groups sit above subscriptions in the Azure hierarchy. They can be nested, allowing for a multi-level organizational structure. At the top of the hierarchy is the root management group, which is automatically created. Subscription management. Subscriptions are organized into containers called management groups. A single management group can contain multiple subscriptions. Subscriptions can only belong to one management group at a time. Inheritance. Governance conditions applied to a management group are automatically inherited by all subscriptions within that group. This inheritance model is consistent with how resource groups inherit from subscriptions, and resources inherit from resource groups. Policy and access control. Management groups allow you to apply policies and access control across multiple subscriptions. This centralized approach ensures consistent governance across your entire Azure estate. Flexibility and scalability. The nested structure of management groups provides flexibility to match complex organizational hierarchies. As your organization grows, you can easily adjust your management group structure without disrupting existing policies and access controls. Enterprise-grade management. Management groups are particularly valuable for large enterprises or organizations with complex Azure deployments. They provide a way to manage Azure at scale, regardless of the type or number of subscriptions you have. Use cases for management groups. Departmental organization. Create management groups for different departments, e.g., IT, finance, marketing. Apply department-specific policies and access controls at the management group level. Environment separation. Use management groups to separate production, development, and testing environments. Implement stricter controls on production management groups while allowing more flexibility in development. Geographical distribution. For global organizations, create management groups based on geographical regions. This structure can help in managing data residency and compliance requirements. Project-based structure. Organize subscriptions into management groups based on projects or applications. This approach can simplify project-based cost tracking and access management. Best practices. Plan your hierarchy. Carefully design your management group structure to align with your organizational needs and governance requirements. Use naming conventions. Implement clear naming conventions for management groups to ensure easy identification and management. Limit depth. While nesting is supported, try to keep your hierarchy relatively flat to maintain simplicity. Regular review. Periodically review and adjust your management group structure as your organization evolves. Start with broad policies. Apply broader policies at higher levels, and use lower levels for more specific policies. Leverage Azure policy. Use Azure policy in conjunction with management groups to enforce compliance and governance at scale. By effectively utilizing Azure management groups, organizations can implement a consistent and scalable approach to managing their Azure resources. This hierarchical structure provides the flexibility and control needed to manage complex cloud environments while ensuring compliance and proper governance across the entire Azure estate. The Azure Resource Hierarchy provides a comprehensive framework for organizing and managing your cloud resources. This hierarchical structure allows for efficient governance, access management, and policy implementation across your entire Azure estate. Let's explore the components of this hierarchy from top to bottom. Management groups. At the top of the hierarchy sits the root management group, automatically created for your Azure Active Directory tenant. Below the root, you can create a flexible structure of management groups. Management groups can be nested up to 6 levels deep, excluding the root level. They allow you to apply policies and access controls that are inherited by all resources beneath them. Azure supports up to 10,000 management groups in a single directory. Subscriptions. Subscriptions are the next level in the hierarchy. They act as a unit of management, billing, and scale. Each subscription can only have one parent management group. Subscriptions inherit policies and access controls from their parent management group. Resource groups. Within each subscription, you can create multiple resource groups. Resource groups are containers that hold related resources for an Azure solution. They provide a way to apply policies at a more granular level than subscriptions. Resources. At the bottom of the hierarchy are the individual Azure resources. These can include virtual machines, storage accounts, databases, and more. Resources inherit policies and access controls from their parent resource group, subscription, and management groups. Key benefits of this hierarchy. Unified policy management. You can apply policies at the management group level that automatically inherit down to all subscriptions, resource groups, and resources beneath it. For example, you could restrict VM creation to certain regions for all production workloads by applying a policy to a production management group. Centralized access control. Azure Role-Based Access Control, RBAC, can be applied at any level of the hierarchy. Assigning roles at a higher level, like a management group, automatically grants those permissions to all child resources. This allows for more efficient access management, reducing the need for multiple individual assignments. Consistent governance. The inheritance model ensures that governance policies are consistently applied across your organization. It becomes easier to enforce compliance and security standards across multiple projects or departments. Flexible organization. The hierarchy can be structured to reflect your organization's needs, whether that's by department, environment type, geography, or any other logical division. Scalable management. As your Azure footprint grows, this hierarchy allows you to maintain control and visibility without becoming overwhelmed by individual resource management. Best practices: plan your hierarchy. Carefully design your management group structure to align with your organizational needs and governance requirements. Use naming conventions. Implement clear naming conventions at all levels of the hierarchy for easy identification and management. Apply broad policies high, specific policies low. Use higher levels for broad organization-wide policies and lower levels for more specific targeted policies. Regular review. Periodically review and adjust your hierarchy as your organization and Azure usage evolves. Limit depth. While you can nest management groups up to 6 levels deep, try to keep your hierarchy relatively flat for simplicity. Leverage Azure Policy. Use Azure Policy in conjunction with this hierarchy to automate and enforce your governance decisions. By effectively utilizing the Azure Resource Hierarchy, organizations can implement a consistent, scalable, and flexible approach to managing their cloud resources. This structure provides the control and visibility needed to govern complex Azure environments while allowing for the agility required in modern cloud operations.